All right, we're going to do photochemical smog 7.2. 7.2. That's LA. Breathe it in. Okay, so photochemical smog is photo from light, so the sun has to be involved with making this smog happen. And the light is the catalyst of the chemistry behind photochemical smog. So it's going to involve the water that's naturally occurring in the atmosphere, this nitrogen dioxide, which does naturally occur, but is way more so because of cars and vehicle exhaust. And so we're going to get into the pollutants that are resulting from photochemical smog and are what make photochemical smog, and kind of a little bit of chemistry behind it. So what is caused by the smog? The same thing that it always is. Burning fossil fuels. Burn and die. So transportation, cars, trucks, trains, planes, anything that moves and burns fuel is going to contribute to this smog. The manufacturing process also contributes to this. Anything that burns fossil fuels to create goods and services. And sometimes creating electricity. If we're still burning fossil fuels to make our electricity, then that's going to contribute as well. The other thing that really contributes to this is high temperatures. Guess where we live? California. High temperatures. So we are very famous in LA for smog because we've got all of the ingredients to make smog. Warm temperatures, lots of sun, except for when it's Santa Ana, pretty calm winds, and this thing, temperature inversions, which if you're doing your module online, you should know what that is, but we'll explain it in a sec. So California is perfect to have these kinds of smogs. And another famous place that also has all 3 or 4 of these ingredients is Mexico City. And there are a few pages in your book you should read about that case study, why these 2 places are related and why they have a lot of smog. Okay, so photochemical smog actually relates to the time of day and people going to work and traffic. So LA has a lot of that too. Hold on, my phone's going. Sorry. Okay, so the NOx in the very, very early morning that are coming out of the cars. So between 6 o'clock to 9 o'clock when everyone's going to work, we're getting these nitric oxides, some carbon monoxides, and then the sun comes out. And the sun acts as a catalyst to convert these chemicals into these chemicals, the NO2s, the carbon monoxide, the hydrogen carbons, hydrocarbons. And then at the end of the day, we've got VOCs, volatile organic compounds, just from industry, cars as well, and sometimes in nature, and they all mix together to give us these more complicated secondary pollutants. And so it's kind of this weird mix of circumstances that create this to happen. So ozone shows up in the middle of the day to late in the day because of the sun creating those reactions. And remember from our previous video, ozone comes from a NOx and a VOC to give us this ozone, but it also needs sunlight to be the catalyst for the reaction. So that's why in the afternoon when the sun's out, ozone shows up. So VOCs again are chemicals that are in solvents, gasoline, those wavy lines that come up when you maybe see your nail polish or put gas in your car or a whole bunch of other things, paint, thinners. They also are from nature. So natural things like even trees let out a little bit of VOCs too. So there are some naturally occurring places for VOCs to show up, but not at the amounts that humans put them out in. So all this makes smog. Put it all together, what do you get? Smog. So I like this graphic over here because it's kind of visuals. So they get the sun. In the morning we get these NOxes. We get the VOCs mixed with it. In the afternoon, the sun bakes it all together and makes some nice ozone, which is the bad kind of ozone because it's down here, not up in the stratosphere. You may have noticed this pan over here, peroxyacetyl nitrate, and it also comes from the VOC and NO2 thing. So not only do you get ozone, you can get some other chemicals, and these pans can persist for a while and they're annoying and they are another contributor to smog, and they can come from tobacco smoke or vehicles. So if you're still smoking, if you're a vapor, you're putting this peroxyacetyl nitrate into your body, and it's causing a lot of problems for you, or it will over time. The main one, big time respiratory issues. I mean, you want to breathe, right? That's kind of important. Okay, so this VOC, what the heck is it? So it's a vapor, volatile organic compound. So it's got some carbon in it. That's what the organic part is. It can change really quickly, the chemical compound. It's got these really strong smells. So when you smell something, you're like, whew, that's probably a VOC. Gas, formaldehyde, glue. Don't sniff glue. What's that whiteout stuff? Don't sniff that. Cleaning products, like I say, Fabuloso, Pine Sol, 409, Windex, air fresheners, anything with a strong smell probably is a VOC. And we, humans, animals, plants, also give off naturally occurring VOCs, but not in the amounts that is creating these pans and these other pollutants. So anything we can do to reduce the VOC level will reduce our photochemical smog. So why should you care? Well, you can have eye issues, nose and throat irritations, liver, kidney damage, cancer. It depends how exposed you are to it. So those ladies at the nail salon, they now wear like those little paper masks because breathing in VOCs all day long isn't good for you. If you know someone who works in like the painting industry or furniture building, or they're working with stains, or at gas stations or in mechanic shops, those are all VOCs you're inhaling all day long, or house painters even. So you need to wear those respirators that help filter out the VOCs to keep you healthy. A lot of workers don't like to wear them because it encumbers them, but it's also killing them if they're not wearing them. Okay, so here's an important website and a video that shows a lot of information about photochemical smog. Please watch it. It is important. I didn't put it in there just because I felt like being lazy. It's got some good information in it. So, what can it do to humans? Well, we've kind of talked about it. It irritates the entire respiratory system. It makes your lungs work less. You can't take in a full breath of air. It's hard to breathe. It hurts. It can trigger, not cause, but it can trigger asthma if you've already got it. You can get headaches. It can make your nose membranes irritated. It can burn your eyes. You ever close your eyes and they burn? It could be from smog. Wheezing, coughing, chest pains, pulmonary inflammation, your lungs, heart attack risk increase. So there's a lot of problems. We're trying to limit and lower our ozone threshold of what we think is allowable, and we have actually done a really good job of it. So these are old numbers because it stops in 2008, but our 2015 numbers are actually below this number, so that's a positive thing. So the ozone basic stories right here. I'll give you a little more complicated one, how ozone forms. I think it's in the next video. It's coming, don't worry. Okay, click on this website. It's got really good information. And then here's what you should know. 7.2 is not big. So just the chemistry of how the smog forms, which was that little video over here. Like what's going on? How do we form it? Wait. Oh, rude. Anyways, okay. What are the resulting pollutants? It's annoying me. I have to go back to it. What do we get from the smog? The ozone problem. What's the relationship between the time of day and the pollution we get? So remember the morning, the afternoon, and the evening, what smog pollutants are formed. What is a VOC exactly? How do we reduce the smog? We reduce the VOCs. So stop using those products or buy products that don't have those solvents in them. And there are some that are VOC-free products. A lot of our paint for our houses now have that. The nail polish is acetone-free. And if you pay attention, you can like find a whole bunch of stuff that's free from VOCs, and then know what the human health effects are for the smog. So get that into your AP Comp book, and we will talk about more air pollutants in the next video.